Yeah, so we are going to start with probability, the seventh chapter. We have already finished the first six lessons, all right? So last lecture we completed with permutations and combination. Before starting with probability, it's important that you completely understand the previous lesson, completely go through all the topics of permutation combination, and then you can start with probability, all right? So what do you mean by probability? Probability is nothing but um, chances of something happening or how likely something can happen. For example, for example, um, if I tell you if a statement it is likely to rain today. Okay, if I give you a statement, it's likely to rain today. What does that mean? Likely to rain today मतलब हाँ बारिश हो सकती है. But can you ever give you a guarantee that it is definitely going to rain today? No, right? We can't do that, correct? So chances of something happening, that is what is called as probability. We'll say no, whether you can come tomorrow, probably I'll come. Means mostly I'll come, but can't say whether for sure you're going to come or not. All right, or something like that. I suppose chances of your team winning in the tournament. Of course, chances are there that you can win in a tournament, but no one can give you that guarantee that you can definitely win. Okay, so chances कोई एक thing happen होने के लिए, those are called as probability, but there is no guarantee. No one can tell you that it is definitely going to happen. All right, so that is called as probability. So what we can do is we have to basically learn about few types of events in this lesson. Um, about probability, then a few theorems like addition theorem and conditional probability as well. Let us quickly go through a few things. These things you also had it in your school days. The first thing is random experiment. Okay, first thing is random experiment. What do you mean by a random experiment? Suppose the very basic example of probability that we all have been taking since school days is tossing a coin. Okay, coin toss kiya. So we know that what are the possible outcomes, right? Possible क्या आने वाला है, heads आएगा या फिर tail आएगा. But we know that likely ये दोनों ही आएगा, but we can't predict correct कि exactly क्या आने वाला है. So that is nothing but called as a random experiment. It is nothing but an action which all the possible results are very well known to us in advance. Okay, so that is called as random experiment. या फिर अगर die का भी example ले लो, when a die is rolled, we know that 1 2 3 4 5 6 यही में से कोई एक नंबर आएगा, right? So when we already know the answers before, okay, in advance, so that is called as a random experiment. So the next one is nothing but outcome. Okay, outcome, as I already said, जैसा tossing के coin में we know that heads and tails है, so those are nothing but the outcomes of the experiment. अभी die है, so die when I roll, so those numbers, right, 1 2 3 4 5 6, those answers coming up, those are called as outcomes of the experiment. All right. um and the next one, equally likely outcomes. Equally likely outcomes मतलब जो भी आंसर्स है, जो भी आउटकम्स है, जितने भी आंसर्स है, सबको इक्वल चांसेस मिलेगा. फॉर एग्जाम्पल हेड्स एंड टेल्स वाला ही इफ यू टेक, उधर what is the chance for heads and chance for tails, दोनों को इट इज एग्जैक्टली इक्वल, करेक्ट? ऐसा नहीं है कि हेड्स आने के 70% चांसेस है और टेल आने के 30% चांसेस है. इट्स नॉट लाइक दैट, राइट? एग्जैक्टली दोनों में से कोई भी आ सकता है. वी नो व्हेन अ कॉइन इज टॉस्ड, या तो हेड कैन कम या तो टेल कैन कम, तो दोनों का इक्वल चांसेस है. सो दैट इज कॉल्ड एज इक्वली likely outcomes. All right, so the next one is sample space. Sample space is nothing but the set of all possible outcomes of a random experiment. The set of all possible in the sense, suppose coin is tossed twice. Okay, so all possible. दोनों बार heads आ सकते हैं या दोनों बार tail आ सकते हैं. The first time head, second time tail, या first time tail, second time head. So these are all the total possible outcomes का जो है, that is called as a sample space. Everything put together is called as a sample space. All right. So the next one is event. You all have done this everything even in your school days. It just like a quick revision. Event matlab, event is nothing but जैसे we did what is sample space, event is a part of sample space or a subset of sample space. As I said, sample space में when a coin is tossed twice, I know that all possible outcomes are दोनों में head जाएगा या दोनों में tail जाएगा, first में head जाके second में tail जाएगा, या फिर first में tail आके second में head जाएगा, right? So these are all the possible sample space के outcomes. और फिर इसमें event will be one amongst those, one or two or three, or probably or even like everything. So that will just be like a subset of that. For example, if I tell you event may, um, that case where you get both heads. Okay, so either say HH will be that event. All right. So we're going to solve each and like much examples of these things. So before that, let us just do quick some parts of theory. Okay. So that's also important. So next is types of events. Types of events. Okay, so we have a few types of events. The first one is nothing but simple or simple or elementary event. What do you mean by simple or elementary event? It's that event when the outcome, right, it's a single number or a single element. जैसे एक ही आंसर आएगा उसका. For example, coin tossed twice में ही when the outcome, if they tell you what are the chances that it is tails both the time, so there is just one chance, right, कि दोनों बार tail आएगा. So that is what is called as a simple or elementary outcome. All right, so the next one is occurrence and non-occurrence of event. Okay. So suppose agar die is thrown, let us take. So this is nothing but the sample space we all know. 1, 2, 3, 4, 5 and 6. ये सारे उसके sample spaces हैं. इसमें suppose if they tell you A is an event जहाँ पे it's a multiple of 3 suppose. Okay. So multiple of 3 we know which are the numbers from here which are multiples of 3. 3 ones are 3, 3 to the 6. So these are the two numbers. These are multiples of 3. Now suppose ये तो occurrence में आ गया, right? So this has occurred and we have got 3 and 6 which are elements of the sample space. Now suppose if there is any other number from the die, if suppose the die shows number 5, if the die shows number 5 which is not there, correct? So that is called as A has not occurred. What was our question? The number that appears on the die should be a multiple of 3. So A में अगर 3 6 आता है, only then it will be like occurrence. But अगर die में 5 आएगा, means that event is not occurred. Correct? Okay. Okay. So now the next one is sure event. It's important that you understand these because they may give you examples or ask you questions like what type of an event is this, or give examples of these types of events. Right? They can ask you questions like those. So sure event, as the name says, an event which consists of sample points of all the sample points of the sample space. That is called as a sure event. Now, for example, agar cards wala example we see, cards wala sums we had dealt it, right? Last time we have 52 cards in a pack of playing cards. Usme se we know that 26 are red cards, 26 are black cards, correct? Suppose if I give you, let A be an event that the card drawn is either a red card or a black card. Okay, either red or black. मतलब black. हमको पता है कि there are 52 cards और red और black के अलावा तो there are no colors, correct? You cannot have a green card, you cannot have a blue card, correct? So अगर मैं बोलूँ the card picked up is either a red card or a blue card. मतलब of course, so that is like covering all the sample points of the sample space, correct? Because the entire sample space that you had was having 52 cards in total, which comprises of red 26 and 26 black. So pura ka pura it is covered. So that is called as a sure event. Matlab it is going to happen, right? So the next one is iska ulta impossible event. Okay. Suppose, Abhi, I'll take the same example of the die. Die is rolled. This is the sample space we get. Sorry, this is the sample space we get. Now, suppose if they tell you chances that the die shows number 7. Number 7. But we know that this is not possible, correct? Number 7 is not possible only in a die. It can only have these 6 numbers. So this is called as impossible event. 7 number to hota hi nahi hai na. So that is something called as impossible event. So 5, matlab there is nothing. This is means nothing. You can denote it using 5. Now 5 means nothing. There is nothing in the event. Okay, no elements in the event. All right, so that's called as an impossible event. Okay, so now the last one. The last one is complementary events. Okay, complementary events. Abhi, suppose if I tell you that complementary are exactly ulta. Okay, so complementary is exactly ulta. Suppose if we take that example of a coin is tossed twice, two coins are tossed. So this is the sample space as we know. इसमें से if A is an event that the coin toss shows both tails. Okay, both tails. So what is that only outcome? Both tails is this last one, correct? TT, right? So this is the only outcome. So we have number of elements in A is equal to 1. There is only one element. So this is actually simple or elementary, correct? Okay. So now what will be the complement? Complement will be that A ka complement will consist of those elements which are not there in A, of course, right? But it should be there in the sample space. A का complement will be those elements which are not in A, but of course they have to be present in the sample space, right? Sample space के ऐसे ऐसे events जो भी A में नहीं है, वो सब A complement में आता है. A complement is उल्टा of A, alright? So we have these elements. These are not in A, but yes, of course, in the sample space, correct? So that is nothing but number of elements in A complement is equal to 3. Okay, so that is nothing but A complement is equal to 3. But when you see, when you add both the numbers, since हमने A में कुछ elements लिए और A complement में sample space के ही elements, but जो A में नहीं है. So at the end, when you kind of add both the two, okay, add both the number of elements 1 plus 3, so that will always be equal to number of elements in the sample space because you doing everything with respect to the sample space only, correct? All right, is it clear this much? So we dealt with types of events and this tiny experiments, sorry, tiny definitions. So the next subtopic is algebra of events. So you again have a few types of events, but not exactly types, but something extra about the events, like union of events. Okay, the first one is union of events. Suppose if union is always denoted using A union B. Okay, this U stands for A union B, and the meaning of A union B is either A or B. No, so not either A, to be more precise. X, suppose X is an element, okay? X is an element of A union B. Suppose हम A union B को ऐसे लिख सकते हैं. All the elements of X such that X belongs to A or X belongs to B or दोनों. So instead of calling it either, we could call it both. A में भी B में भी और okay, so either A में belong करता है और B में belong करता है या फिर दोनों में belong करता है. So that is called as union. Union is nothing but to be making it very simple. All the elements जो भी A में like करता है और B में like करता है, everything that put together is called as sample A union B. Suppose if we have a sample space and the sample space consists of all positive integers, okay, all positive integers up to 50. Up to 50, all right? So up to 50 mein what all numbers can come? All positives. 1 2 3 4 so on and so forth till 50. 50, right? Just a second. Okay, now suppose if A is an event, that is set of numbers that is divisible by 6, if we say divisible by 6. So which are those numbers that can come under event A? All that are divisible by 6, correct? So 6, 12, 18, 24, 30, 36, 42, 48. But that's it, because the sample space was only having elements till 50. And suppose if we take B is another event that is all set of all elements that is divisible by 9. Okay, so B will have these types of elements. Just a second. Okay, so B is nothing but set of all elements that are divisible by 9. So which are those elements that are divisible by 9? The elements of B will be 9, 18, 27, 36, 45. That's it. Okay. So now how will we write A union B? A में है या B में है और फिर both. Okay. So that will be like a combination of both. So we'll start with the smallest. Don't write A first and then B. So we'll write start with the smallest and then we'll go in the order. 6. Then we have 9, 12 है, 18 hai. You see, 18 is coming in both the places. Huh? 18 is coming in both the places. That doesn't mean you will write 18 twice. Just write 18 once only. Then we have 24, 27, 30, 36 again coming in both the places, but we only want to write it once. 42, 45, 48. So that is nothing but both. Okay, so combination of both. But writing it only once if it is repeating. That was about union. The next is exhaustive events. Exhaustive events again. The definition of exhaustive events, if when you have two events, say A and B, you can call the two events A and B exhaustive. If when you take the union, I know we know how to take unions, right? मतलब दोनों का combination, right? That should be equal to the sample space. Suppose अभी see now over here the entire sample space was 1 to 50, but यहाँ के जो elements है सारे के सारे on taking A union B is not like it's not equal to sample space. There are many elements in the sample space which are not there in A union B, correct? So suppose if something like this, if you have sample space or of a diazole, so this will be the sample space and उसमें से suppose A is an event that shows numbers which are less than or equal to 4. Okay, it is a set of numbers that are less than or equal to 4, less than or equal to 4. So what are those numbers? 1, 2, 3, equal to 4 also they tell you, so 4 will also be counted. Okay, now suppose B is an event which shows numbers greater than or equal to 2, suppose. So which are those numbers that are greater than or equal to 2? Equal to 2 means, of course, 2 is counted greater than. All the numbers that are greater than 2, of course, with respect to the sample space only. So now when you take A union B, as I said, both. So 1, 2, 3, 4, 5, 6. Now when you clearly see A union B is same as the sample space. So there is no change. So A union B, when it entirely comprises of the sample space, you can call it a exhaustive event. Okay. The next one, intersection of events. Intersection is like union ka ulta. You denote it using A intersection B. Union में you have U, intersection में like this. उसका उल्टा, okay? Suppose if we have something like this, or let us consider the same example of above. A is a set of all positive integers 1 to 50, where A is divisible by 6, B are all numbers that are divisible by 9. When we have to find out A intersection B, intersection मतलब वो elements which are common to both A and B. So which are the numbers that are common in both A and B? A में 6 is there, B में 6 is not there. 12, 12 not there. 18, yes, of course. 18 is matching, which are there in both the numbers. 24, no, 30, yes, 36. So 36 is the number that are present in both the events, correct? So 18 and 36. So 18 comma 36. So that is called as A intersection B, which are present in both. matlab both matlab that's together, right? Intersection. So that is called as and. A and. Union में it is A or B. Intersection में it is A and B, right? दोनों में present होना चाहिए. Both of them, all right? I think the last one is mutually exclusive. Mutually exclusive events. Now these are those events that are mutually exclusive, means they're exclusive, एकदम अलग. Mutually disjoint, मतलब they don't have anything common, nothing common in their intersection. उनके intersection में there is nothing common. Nothing common means how can we write A intersection B is equal to 5. 5 means nothing, right? So A intersection B are, you can call them disjoint. When you don't have anything common in them, we can call them disjoint. If A intersection B is equal to 5, but there is nothing. So we can write anything. Okay. Suppose if I take an example of when a die is rolled. Okay. 1, 2, 3, 4, 5, and 6. Let A be an event which is a multiple of 5. Okay. Multiple of 5. So we just have this one element. Multiple of 5. Suppose B is an element which is a multiple of 2, suppose. Multiple of 2. Which are those elements? 2, 4, and 6. Can we have anything in common? Do we have anything in common to A and B? No, right? There's nothing common. So these are two mutually disjoint or mutually exclusive sets, events. So they don't have anything in common. So that's nothing actually. So A intersection B, you have no elements. So you can write it like this. So that's equal to 5 only anyways, because you don't have anything in common to them. Okay. Now suppose a question that we have, all the types of events and everything we have finished. Let us come to questions now. Suppose if they tell you, write, this is a small example, sample space of the experiment, coin and a diathrone simultaneously. Simultaneously means both events happening together. दोनों एक ही साथ, so both happening together. All right. So that is what is called as simultaneously. When two things happen together, we call the two things are happening simultaneously. So what are the two things happening simultaneously? Coin is also tossed, die is also thrown. These are the two things that are happening simultaneously. So we know what can happen. Abhi, when a coin is tossed, you can either have a H or you can either have a T. Correct. When a die is thrown, you can have 1, 2, 3, 4, 5, 6. अभी जब दोनों साथ में हो रहा है, so that will be nothing but like a combination of both, correct? So what should be our sample space? This element with all the elements, this element with all the elements. So we'll have h comma 1, the first head with all the numbers, h comma 2, h comma 3, heads when the die shows 4, heads and the die shows 5, heads and the die shows 6. Likewise, whatever we did it for heads, we're going to do the same thing for tails. Tail and the first, die shows number 1, tail and the die shows number 2, tails in 3, tails in 4, tails in 5, tails in 6. All right. So this is nothing but the sample space when both the things are happening simultaneously. So when they are talking about two things, you write sample space of the first one of the second event. So दोनों का जो combination है, then you write that is nothing but the total sample space. Okay. Let's take another example. Suppose if they give you, and all times we've been dealing with one coin is tossed or two coin is tossed. So this time three coins are tossed, right? Three coins are tossed. So there are four events happening. You have to write down the sample space and the events, okay? Number of elements in the events. So what will we do? Suppose there are four events. Let us name them E1, E2, E3. Okay. Suppose let us name them E1, E2, E3 and E4, right? So these are the four events. E1 is that event where the occurrence of um, at least two heads. We have already saw sums of at least wala cases in permutation and combinations to be more precise. So at least is nothing but come say come two heads. More than two heads, of course it is fine. Okay, so the next event is at least two tails. And the next one, at the most one head. At most one head. At most one head means ज़्यादा से ज़्यादा one head. More than one head will not do. कुछ भी head नहीं है, that is also okay. Okay. So the fourth event is occurrence of two heads. Two heads, all right. So let us first quickly write on the sample space. What will be the sample space? There are three coins tossed, right? So always please remember in this coins types of problems, the number of elements in the sample space will be equal to 2 raised to the coins tossed. Okay, 2 raised to n. N is nothing but coins tossed. Okay, number of coins tossed, the number of times the coins are being tossed. So that is nothing but n. Suppose, for example, if one coin is only tossed, agar one coin is only tossed, so there are 2 raised to 1, only 2 elements in the sample space. That will be only h and t. So 2 elements again. Na? Suppose agar 2 coins are tossed, so that will be 2 raised to 2. That power is nothing but the number of coins tossed. So that becomes 4. So क्या रहेगा h h h t t t t h that we just wrote. Abhi here it is 2 raised to 3. So we'll have 8. So you should not miss in the exam. You should count if it is 8. Matlab it is correct. So we'll have all three heads. HHH or HHT, HTH, then THH, then THT, TTH, TT, 1, 2, 3, TTT, 1, 2, 3, 4, 5, 6, and then HTT. Yeah, that is remaining. Correct. So these are the 8 ones. To be more precise, we can write it over here. All the H's will be together. Yes. HTT, and then here it is THH. All right. Now the number of elements in the sample space is equal to 1, 2, 3, 4, 5, 6, 7, 8, right? 2 raised to 3. So that is 8. Okay. Now each and every events we're going to find out what is the number of elements in that event. Suppose E1. What was our E1? At least 2 heads. At least 2 heads. I've told you. कम से कम 2. More than 2 heads, of course, चलेगा. So यहाँ पे we will see कि एक elements you see individually whether it has got कम से कम 2 heads. कम रहेगा 2 से कम, then it is not okay. हाँ, the first one has got 3 heads. हाँ तो चलेगा ना हमको. We just want कम से कम 2. So the second one will also do. It is having 2. Third one that will also do. H T H. This one, this one, this one will it do? No, this one will not do because it has got only one head, and they said at least 2. So that will also not do. This one, no, this one will also not do. This has only got one head. This has only got one head. Ha, this one will do. T H H. Right? So elements in the even number 1 is equal to 1, 2, 3, 4. So that's equal to 4. Okay, so you can just write the elements. Counting is not a problem. So we'll just quickly note down what are the elements in that particular event, and then counting is not a problem. So we'll not do that. At least 2 tails. At least 2 tails. Come say come 2 tails. More than 2 tails is also okay. So we'll do that on a similar basis. फर्स्ट वन टेल, इसमें नहीं, कम से कम 2 है, नहीं इसमें तो 1 है, हाँ दिस वन विल कम से कम 2 है इसमें, हाँ कम से कम 2 है, THT इसमें, yes we have 2. The next one 3 है, okay, more than enough. Again this is also got 4 elements. What was our third event? Third event was at most one head, at the most one head. ज्यादा से ज्यादा only one head will do, two heads will definitely not do, and heads नहीं भी रहेगा तो भी चलेगा, तो दोनों में ज्यादा से ज्यादा एक ही होना चाहिए, एक से ज्यादा नहीं होना चाहिए. So that will be this one. Oh god, 3 heads are there, यहाँ पे 2 heads, no 2 heads, this will also not work. This is 1 head, so yes that will work because इसे ज्यादा से ज्यादा एक ही चलेगा, एक से कम भी चलेगा. This okay, 1 head. This okay, TTH. This one, no heads. That is also okay. TT. Okay, so this has also got 4 elements. What was the fourth one? Occurrence of 2 heads. To 2 heads, you see exactly where there are 2 number of heads. Instead of writing it over here, I'll write this is 2 heads. 2 heads के लिए. This one we will write. This one we will write. And this one we will write. So these are 3 places where you had exactly 2 number of heads, correct? Okay, yes. So these are E1, E2, E3. Suppose after this much, if they tell you, if they give you another question, okay, they initially told us to find out the sample space. They also told us to find out the elements of these events, E1, E2, E3, and E4. Now they're giving you another question, continuation, okay. Find E1 union E4, also find E3 ka complement, okay. So you're going to find out these things. Also check if this is with respect to the above question only. Also check if E1 and E2 are mutually exclusive. The next one, E2 and E3 are equal. Okay, yes, so we're going to find out E1 union E4. So E4, right? So we need E1 and we need E4. So these are the two things. In दोनों का union we're going to take. So HHH will write, HHT will write, HTH will write, THH will write. Okay, so इसमें से these three are already repeated. HHT, HTT, sorry, HTH and THH. So ये तीनों things are repeated same over here. So we are going to write everything. ये दोनों तो repeat हो रहा है, ये तीनों. So we'll write that once and this one also. So let us write. So that is nothing but HHH, HTT, HTH, THH. All right. That's E union E1 union E4. Next thing they told us to find was E3 का complement. मतलब जो भी E3 में है उसका उल्टा. But which are there in the sample space. So this is E3. Okay. E3 and this is the sample space. So HTT E3 में है. HTT E3 में है. So this we will not write. So can I use another color so that it becomes easy? All right. So HTT is there, so this we will not write. THT we have, this we will not write. TTH we have, this we will not write. TTT we have, this we will not write. So all the remaining ones that we will write in E3 ka complement. Okay. Okay. So those will be HHH, HHT, HTH, THH. So now they're asking you, we have found out E3 ka complement also. Now what did they tell us to check? They asked us to check if E1 and E2 are mutually exclusive. What was the definition of mutually exclusive? When they don't have anything in common, correct? So let us see. E1 intersection E2. What is that? E1 intersection E2. Are they having anything in common? Let's check. HHH नहीं है, HHT नहीं है, HTH नहीं है, TTH नहीं है. Okay, so they don't have anything in common, right? So E1 intersection E2 is nothing, right? So that's actually equal to 5. So yes, E1 and E2 are mutually exclusive events. Okay. Now the next one. Last question. They asked us to find out if E2 and E3 are equal. E2 and E3 are equal. उन्होंने check करने पड़ा था. So let us check. We can clearly see, right? They are equal. HTT, THT, TTH, TTT. So yes, E2 and E3 are equal. When they ask you check means you have to check. है तो है, otherwise नहीं. Then you have to write. But in case if they tell you prove that it is equal, so yes, like how we start with that left hand side and then come yes right hand side that is also equal. So that we will write. Okay. Okay. So now few things or few rules or properties of probability we can start. That is nothing but concept of probability. Under that we have a few topics to be done or few rules to be done. When we know that we have an event A, we have an event A dash, that's nothing but complement of A. Always probability of the complement will be nothing but 1 minus probability of that event, and likewise probability of A will be 1 minus probability of complement. So this thing you have to remember. All right, so these are one topic. And probabilities ka value can never go beyond 1. It will always be between 0 and 1. For this rule, agar either the answer if you're getting that as 1.5 or something like that, then that is wrong. That's not possible. All right. And phi, as I said, suppose when हमने mutually exclusive देखा था, when the events were disjoint and we don't have anything in the elements and the set, so that is called as null set. Okay, and probability of that event is 0. So these are the few points you have to remember. Okay, complement ka probability is always equal to 1 minus probability of that original set. Probability ka values can always take numbers, I mean values between 0 and 1. It can't go beyond 1. If it is going beyond 1, then it's wrong. All right. um, Phi null set, when you don't have any elements in the events, uska probability will be equal to 0. Suppose if we have two events, something like this, if A is a subset of B, मतलब B के पास elements है 1 2 3 4 and A है 1 2, so we can clearly see that A is a subset of B, then probability of A will always be less than or equal to probability of B. That you have to remember. It's not like you have to remember subset है तो उसका probability will be less than or equal to that probability. All right. And um, the last one, if A and B are any two events, then we have, this is one thing which you may have to remember. A intersection B complement will always be probability of A minus probability of A intersection. These are like very well can be, especially the fifth one can very well be explained with the help of Venn diagram. But right now we're not doing Venn diagram. So this one property you can remember, which you may be using while solving problems. Probability of A intersection B complement is probability of A minus A intersection B complement. So whatever that remains, B so that is called as B complement. All right. So these are the few topics, properties that we dealt with, and let us solve a few sums based on this. All right. Based on this, we can do. Uh, Suppose if a question given to us is something like this. If we have A, B, and C, there are three events, okay? And if A union B union C is equal to S. There are three events, and when you take union of all the three events, you get the sample space. So, and another information given to you is A, B, and C are mutually exclusive. Mutually exclusive, they're disjoint or when they don't have anything common inside them. So the question is, can the following represent probability assignment? I'll tell you that. Suppose if they give you these values. Probability of A is 0.2, probability of B is 0.7, probability of C is 0.1. Okay. Can this represent a probability assignment? So probability assignment basically means what? Sometimes, see, we know that this is true, right? A union B, a union C is equal to S. So when you take the probabilities, that will be equal to probability of sample space will be equal to probability of unions of the sets. This is always equal to, there is something called as an addition theorem, when you have probability of A union B will always be equal to probability of A plus probability of B if A intersection B is nothing, is zero. Okay, when you don't have anything common in between those unions जो sets तुम लोग ले रहे हो, then the probabilities can always be added. So यहाँ पे we know that A, B and C में there is nothing common, right? It is just given to us, no? They're mutually exclusive, means they don't have anything common. So we can always add the probabilities. Probability of A plus probability of B plus probability of C. So we're just having all the values. So let us just put it everything together. A is 0.2, B is, this is 0.7, okay, plus 0.1. So what do we get? 0.9 plus 0.1. So that is equal to 1. So yes, of course, वो सबका this thing should be less than 1, correct? What did I tell you? The probabilities of the entire thing should not go beyond 1. It can only be between 0 and 1. So yes, it is satisfying. And not just that, तीनों का probability values of all the events, probability of A, probability of B, um, it stops sometimes. Okay, probability of A, probability of B, probability of C. So all these events ka probabilities are clearly between 0 and 1. See 0.2 here, 0.7 here, 0.1 here. So they're all clearly between 0 and 1. And of course, that entire probability is not going beyond 1, right? So yes, this represents probability assignment. All right. So this you can just try. These are using the properties that we had dealt before. So that's it. So it is just named as axiom 1, 2, and 3. Axiom is nothing but property only, some truth that we always accept and then use it. So those are nothing but called as axiom. They're same as property. In the textbook, just the word axiom is used. So don't worry if something like that is used. Okay. Now, if you have another example like the same question, huh? Same. A union B is equal to C and they're mutually exclusive. But this is the numbers they're changing this time. Let us see what happens. Suppose probability of A is 0.4, probability of B is 0.6, probability of C is 0.2. So you kind of add both the three. Probability of S will be A plus B plus C, correct? Because they are all disjoint, so it can be added. So what we'll write? Probability of A union B union C. This is probability of A plus probability of B plus probability of C. When you kind of add up all, you get 0.4 plus 0.6 plus 0.2. That comes to 0.4 plus 0.6 is 1. 1 plus 0.2 is 1.2. So that's not equal to 1. It's going beyond, right? So probability of the sample space should be equal to 1 only. So it is going beyond 1. It should compulsorily be equal to 1. Only then it is possible. But here it is going beyond 1. So they cannot represent probability assignment. Okay. Mm, so let us cover up a few more tiny examples. I think these all you all know it already, but we can just do the tiny examples. Now suppose a word problem that we have, in case if the question is something like this. Yes, a question something like this. This is a cards wala question. Suppose if they give you a question like one card is drawn, of course, from a pack of 52 playing cards that we know it already. What is the probability that what is the probability that it is king or queen card? Okay, king or queen card, that you have to find out. We know that this is like combination problem. Of course, last time I told you all when we did a combination problem, whenever it is like card is drawn or card is selected, it's always combination. So we have a total of 52 cards, but right now we're dealing with probability, so we need something called as a sample space first, correct? So we have a total of 52 cards. Let us start with the solution. So out of 52 cards, they're talking about drawing just one card, right? One card is drawn. One card can be drawn in or can be selected in 52C1 ways, correct? 52C1 out of 52. We're selecting one card. So that will be done 52C1 ways. So that is your entire sample space. That is 52C1. And NC1 का answer is always equal to N. So that is equal to whenever you have to just select one. 100C1, the answer will be 100. So you don't have to sit and calculate. That's like a property which we've already done. Right? So now coming to events. We're talking about two things or two specific types of cards, king cards or queen cards. So let us divide them into two events. Let event A be that event where the card drawn is a king card. Okay, where the card drawn is a king card. Now coming to kings. So how many total king cards do we have? Of course, we're going to do this with respect to combinations. So how many total king cards do we have? Out of a total of four king cards, correct? We have a total of four king cards. How many cards to be selected? Just one, right? So one card can be selected in out of four. We're selecting one, so that can be done in 4C1 base. So number of elements in the event A is equal to 4C1. That is equal to 4. Whenever you have NC1, as I said, you don't have to calculate. Just write the value of N as it is. Okay. So let your second event B, where the card drawn now is a queen card. Queen card. Again, for the queen, also the same story. Queen also we have four cards, right? So out of four queen cards, how many is to be drawn? Just one card, correct? One card can be selected in 4C1 ways. That's number of elements in the events B is equal to 4C1. That's again equal to 4. Now, what was the initial question? So, coming back to the initial question, they asked us about the probability, correct? What is the probability that it's a queen card or a queen card? But यहाँ पे तो हमने सिर्फ number of ways find किया है. But they asked us about the probability. So, probability of both the events also we have to find out, correct? So, probability of A we will find out, probability of B we will find out. We know that the formula of probability is nothing but of that particular event is number of elements in that event upon the number of elements in the sample space. Number of elements in B upon number of elements in the sample space. What is the number of elements in event A? It's 4. 4 upon number of elements in the sample space. How many? There were 52. Correct? 52. So when you can just write it in the reduced form, this 4 ones are 4. 4 into 13 is 52. 4 ones are 4, 4 13. You can just cancel that and write. Likewise for B, B may be number of elements in B is 4 and number of elements in the sample space is 52. 4 ones are 4 into 13 is 52. 1 by 13. Now the actual last step. They told you it should be either a king card or a queen card. वो दोनों में से क्या? Of course it can't be both because you're just drawing one card और वो या तो king है या तो queen है. ऐसा what is the chance, right? So now we can clearly see what was an event A. A was all king cards. B was all queen cards. So A and B are nothing but mutually exclusive events. Of course, right? इसमें सब queens है, इसमें सब kings है. So they don't have anything in common. So A and B are all mutually exclusive events. So probability of A union B, that's like either king or queen. So that's like addition, right? I've already told you or means addition. So it's P of A probability plus P of B, A union B. And I've told you in the previous sum, union के लिए, A union B के लिए, we can only write probability of A plus probability of B only when they are mutually exclusive, when they have nothing in common. Only then we can write it like that. So probability of A is 1 by 13. B is 1 by 13. So the answer is 1 plus 1, 2 by 13. So that's the final answer. So probability of A union B, that is nothing but the probability that it is a king card or a queen card is actually 2 by 13. Okay. This problems, formulas of probabilities, you all have to remember what is probability of an event. I think that you've already done it in the school days, number of elements in that event upon the number of elements in the sample space. And of course, combinations also you have to be thorough, only then you can do the problems. Later on, this is as the basic. Later on, we'll do even a tougher type of problems. Okay, just a second.